So here we'll continue to work on the definition of classes in C++. And so we are going to look at the definition and the access control with respect to the class and how that can be supported by the definition of elements like being private or public. So the default access specifier is private. So if there is no modifier, everything is defined as a private. The members are typically private or protected. Effectively, they cannot be manipulated outside of the class itself. And so a function that is private is basically for internal use only, right? Because it's not accessible from the outside, so it's not effectively a part of the API of the class itself. And it can only be accessed of the same class. An exception is the friend functions, but again, this is not particularly important as a foundational definition. The public member functions are really the interface of the class that define effectively the behavior of the class, right? And so they really, you can think of that as the abstraction. So if you have complex numbers and then you define math operators, so that's really the interface you use, and that's how think of the abstraction and how the user will look at the class. And so those control section can be repeated and they can be occurring in any order. And this is really to facilitate the fact that the order in which you put things inside the class should really dictated by the readability of the code, not that you're forced to put all the private components on one area and the public component in an area. You can divide the function by components in different way, and each component may have private and public elements to it. So what is an object? An object has a set of methods, members of the function, and the internal state as defined by the class. So effectively, it's an instance of a containing referred to by a variable of the class itself. And so you have for all the data, all the description internal state, I guess, except static ones, there is a whole copy. And so every object has its own internal state, and the operations, the set of methods operate on the state itself. So every instance will be, in some sense, independent from the other, again, except for static members. So here we look at a basic example of the rectangle again. So we have a private width and length and then set an area. So if we use this in a main program, we can define two rectangles and then set the dimension of one rectangle and then compute, print the area of the rectangle itself, set the dimension of the other and print the area. Given that nothing is static, so each instance, each object has its own copy of width and length, so the shape of each object will be different. But then the methods operate on the local version of each of those variables in there. So here, a variation on the same concept. Let's say we have a class circle where we store as a private element the radius, and then we have publicly usable, basically storing the radius, calculating the area, and display the value of the radius of the circle. Now this is just, those are only here declared, they're not defined. So externally then we can start saying, okay, store radius, we assign the radius to the value given in input. We look at the area by returning 3.14 times radius squared, and then display is the print function for that circle. So here now we have a full definition of the class circle with all the methods, and then we can use it in a main. And so we define a circle C, assign a radius of 5, and then print the area of the circle, and then print the value of the radius. So this is we have an interface, we have the private information, all the methods are being declared, and then the practical used through the API of the class. Similar here, going back to the rectangle case, typical definition. Here, rectangle R1, and set the dimensions. Now here, R1 is allocated just directly as a variable. And so here is the allocation static of the variable itself, then has its width and length, and then they get assigned directly. Here it's a second case with two rectangles, one of which is assigned statically as a variable. And one is taking declaring a pointer to a rectangle, and then assigning a reference to the first. So here you see all the things that work on fundamental types work on classes. So R2 is a pointer to R1. And so here we can call the same methods, but we have to go through the arrow instead of the dot, as we saw in the previous lecture. So practically, we can think of using this piece of code. And then initially, we get rectangle, say, in location 5,000. We create a pointer that I guess maybe randomly may have pointing to 6,000. Then we assign it the reference to R1. And so the value here is 5,000. It points to that object. And therefore, when we call the set function through the arrow, that for R1, so you see the difference between the dot notation and the arrow notation, it gets assigned the value 810. So yeah, notice again, just a reminder, two way of calling a method. If it's a regular static variable allocation, we use the dot. If it's a pointer, we use the arrow. And remember, this will be probably asked during the midterm. And so there is even a more kind of fully dynamic way of creating a variable of the particular type of a class. So let's say we define a pointer to the class we can use the new operator that creates an instant of a class, in this case of type of rectangle. You look at the parenthesis. So this creates an instance and return the pointer. So that could be assigned to R3. At that point, through the pointer, we can call the set function. And what's important is that after we finish using it, we delete the instance of the class. So every new statement, unless we want to have a memory leak, every new statement needs to be coupled with a delete statement so that every dynamically allocated instance of a rectangle gets eliminated at the end, and then we can set the pointer to null just to indicate that we're trying to do things in a clean way. So this is a full-blown dynamic allocation. Let's say R3 is located address 6000, but it has no value because it's not been initialized. Then we run the new statement, which creates a location where we have an instance of a class. But again, the only connection we have with an instance is the address return, in this case, 5000. If we didn't save immediately this address, basically this would be what we call a memory leak, because this is allocated, but nobody is able to use it because there is no point going there, no pointer going there. And then we can start doing the assignment. And so through the arrow notation, we call the method and assign 80 and 100. Then we delete the object itself, and then we reset the pointer to null. So this is kind of the clean way to use a dynamically allocated instance of a class. Let's go back to the circle case. So we have, we make it a very trivial. We just assign a radius and make it public. So the user would know directly what to do. So we can declare so we can allocate an instance, a static instance of a circle. And then through the dot notation, so it's not only for methods and function, it's even variable itself. If it's accessible directly, in this case it's public, we can assign directly the radius of the function, the radius of the circle with the dot notation. So we can do the assignment, but obviously this works only in the public members. It's kind of highly not recommended, so highly discouraged to do things like this, because the whole point of having a class is that one access all the elements through operators, that it's careful to do always the right thing instead of just having full access to all information directly. So here is the proper way of doing a circle, private radius, and then we have both methods now inline, just for simplicity, radius and set radius and get radius. And so then we can create a circle, set the value, and then print the value with a get function. So you see, it's not a huge difference. It seems somewhat complicated, but has the big value of protecting the internal representation, so that someone using the class that does not know the assumption of why you use a certain type of information and so on is not going to change it directly and potentially create a problem. So it's really an issue of clarity and abstraction that otherwise would kind of go away. And again, so you selectively make available only the member functions. So here we go again to the different use of arrow and dot notation. So class rectangle, private description, public API, and then we can create an instance of a class, and we can refer to that through a pointer and manipulate the class directly. So the initialization of the class, it's very important. So far, we have been working with this set function, but between the creation of the object and its set function, basically there was a non-initialized state that is not to be recommended. So the constructors are particular methods that are meant to initialize the content of the object at creation. So there is no gap in time between creating the object and making sure it's in a proper state. So the default constructor is the constructor with just open close parentheses, and by default basically doesn't do anything. But then we can create different constructor. For example, one possible constructor is what we call the copy constructor. So we give, if we want to create a copy of a rectangle, we can provide a reference to a rectangle, and then the new instance will make a copy of the dimension. Then you have two rectangles that are separated, separate objects, but they have the same value. And of course, one can create directly a rectangle by provide width and length. So those are all publicly accessible. They have the same name of the class, so that's how you tell a constructor. You will see later the destructor has a tilde in front, and they don't return any type because their work is just to set properly the state of the function of the class, and then the system would know whether it's being created used by a new that return a pointer or just initializing a static variable. And so they will have different signatures, so different set of input parameters, so that the compiler for every instance can decide which constructor is better suited for a particular use case. And so implicitly, the default constructor and a copy constructor are created if nothing is being declared. And in particular, the default copy constructor effectively copy all the variables inside. So unless there is some dynamic allocation, actually, the copy constructor works okay for a class, for example, like this. So the default constructor for creation of the copy constructor, it simply has no code inside, empty, while the copy constructor really does one by one assignment of all the variables inside the class. And again, if none of those, it's like a pointer to a dynamically allocated piece of memory, the copy constructor by default works just fine. So one can initialize a new default constructor. And so if you do a new, or if you define a static variable, the default constructor is being called. A copy constructor instead is being used if you create an object, an instance of the class, and then you start creating new copy. So in this case, for example, rectangle R5 equal R4. This is assigned at creation, is going to call the copy constructor. If we create a new variables, there's another way effectively to have the same semantic. And or if we create a pointer with a new, then you pass as a parameter. This is actually the reference, and so it does not get copied as a call in the function, but then we get a copy in the object referred by R7. So if we define some constructor and not others, so the default constructors is not created. So there is a difference between defining no constructor or defining a specific one. So if we define one, it is implied that in some sense we know what we're doing. And so if we choose to not create the other default constructor, they don't get created at all. So there's no default in that sense. So this means that we expect all, in this case, to all the rectangles to be created not as a copy of something else, not as empty ones. They always have to have width and length. So rectangle R4, the empty constructor, it doesn't exist anymore, so it will give you an error. You always have to call with an initialization. Obviously here you have the same problem with a copy constructor. So, and those are legal uses that is not legal anymore. So writing your own constructor is very simple. So you create your signatures, and then you just in the definition you put the proper code. Let's say the rectangles by default have shape 20 by 50. This would be the default constructor with no parameters, right? And so when you create a new rectangle, this is created with a new, and so you get a pointer that refers to an object where the dimensions are 20 by 50, because that's the default that has been created. So this allows to give more control. So here we have another simple example of account. We look at the name, balance, and the ID of the account. And then we have a few constructors, one for copy, one for no parameter, and one with a particular value. So instead of running the risk of having uninitialized elements, like for example, the pointer and so on. So even if the account is empty, one can initialize the values to be null, 0 balance, and 0 ID, for example. And so that we always guarantee that the variable of type account is in a proper state. The copy constructor allows to deal with dynamically allocated data. So for example, here we have the string of the name. And so if we're copying an account, we want to create a new string. So the name is a pointer, so we have to create a new string and assign the pointer to the first character in the string, and then we make a copy of the string. So this is important, and this is actually one of the things that typically leads to bug that might take a long time to figure out, because the two classes that are copied without this dynamic allocation, they could point to the same string, and for quite a while you may have a situation where two people have the same name, and instead of having two separate strings, the instances point to exactly the same string, and until there is a situation where you want to change the name of one and not the other, or one gets deallocated and not the other, this can appear to work just fine, but is not. And so the copy constructor is very important, especially in those situations where there is any kind of dynamic allocation. The balance, so copying the balance is trivial and copying the ID is trivial, but the part that is more interesting is the allocating the space for a string and then making a copy, because that cannot be done by direct assignment. So, and here's the case of assigning a name. And again, the implementation is not quite as trivial as it might seem. We cannot simply say name equal to person, But what we want to do is in name, make sure that we allocate a string that has enough space. So an array of characters enough space to store the string plus the null, the /0 termination. Then we can do a string copy from person to name, and then we can allocate the balance and ID to 0. So as soon as we have something dynamic, like a string, an array, and so on, it's actually important that we carefully design this type of functionalities. So far we have looking at objects and how they're being initialized and manipulated. We'll be looking at constructors, either default one, copy, and other with parameters. We'll be looking at the concept of allocating resources where when objects are allocated or even when they are modified. For example, here in the case of assigning the name, we had to allocate dynamic the resource of the array of characters or the string. And now at the end, when we stop using that, we have to make sure that those resources that we have been allocating can be revoked so that we reclaim the memory that is being used. And so that's where we look at operators, so methods that kind of do the cleanup, also called the destructor. And those are really kind of as a symmetry to the constructor that has exactly the same name as the class. The destructor has tilde and the name of the class. And similarly, so the destructor has tilde account no parameter. For example, if we allocated the name as a new of a set of characters that can be matched with a delete function that allow eliminating the storage of the array. So this is it's a special method, has no argument, because that happens when you're closing and cleaning up. It gets called often when the variable goes out of scope, unless it's allocated dynamically, in which case it's being invoked by the delete operator. But if it's a variable inside a function and the function goes out of scope, that gets called automatically. So a very simple example just to put all the elements together. So let's say that we have a class string that we want to use to manipulate string with some level of abstraction. Here we have the char star part of where we store the actual sequence of characters. We can have an integer that gives us the length of the string. And then we can have constructors. They allocate an empty string, a copy of a string, or get a reference to a string. We can access the data by the string itself or the length of the string, and then we can destroy it. So a constructor can be creating a by default. So when you have an empty string, you still allocated a character with a /0, and we said that the string has length 0. We can have a constructor through given a pointer to a string, and then we allocate the space, copy the string, and then set the length. Or we can do the constructor through a reference of another string, so not just a flat string for which we would have to compute things, but just an object of the same type. So then we copy the length, allocated the array, set the length, and then do the copy of the string itself. So getting the data, basically one return the pointer to the string itself, very simple. One can return the length, but and then also similarly simple is the destruction of the string, where the length is going to be removed naturally, but the allocated space for the data has to be removed with the delete function. Notice how even an empty array will allocate. So in all three cases, we have a new function, so we don't have to make a distinction and check whether the length of the string is positive or not, because even for empty string, we must have allocated an array. And so practically, we can invoke a main in the main, say integer x, create a string with a certain length, and then create a second one and use this directly in our main. So this concludes the discussion of the fundamental features of creating classes, and then we'll provide some more practical experimentation of how things work in the execution of real code. Thank you.